Welcome back to yet another video. Today we are going to discuss about the real interview questions asked in the WIPRO interview question. So the candidate had an experience of between 3 to 8 years, and this was the first round. He got selected, and currently he got an offer of 17.8 LPA. This uh, this whole interview process is related to core Java, Spring Boot, and microservices. Hope this video will be helpful for the people who are preparing and who are going to attend the interview, and specifically if you are going to attend for an WIPRO interview. So this video will be helpful. So watch this video. So the very basic questions any interviewer asks is about tell me about yourself. So I think I pretty much discussed every time like what needs to be answered in this. You have to tell with confidence and also your whole details about what is your education and what is your experience level. Like along with that, all the details, how you, what is your current project or details, right? So, or what kind of domain it is, or what is your experience. So all details you can mention here. Next, this particular question is about the project architecture and also team structure. So basically, many interviewers are fond of understanding whether he has a real experience or not. So he tried to gather information like how many team members are there, what is the project architecture, what was the modules, what was your contribution, right? What was the changes you have done. So overall, if he is trying to understand whether you are well aware of the concepts and also you have practically worked in the project, so check it out and be prepared with the overall project architecture structure and other details in it. Uh, Now, when it comes to overall as an Java, as an object-oriented language, right? Interviewer, if you are a in immediate fresher or like let's say less experience, right? This particular question might be asked so that he wanted to understand whether you are aware of the object-oriented principles and also if you are aware of all those names, right? Along with the exact implementation, right? So there is a possibility that there might be 90 to 100% possibility that whether he asks the OOPS concepts, then he might ask you one specific principle concept in details, right? So here, if you see, basically there are four of them. So one is encapsulation, inheritance, and polymorphism and abstraction, right? So encapsulation is nothing but you are going to bundle your data and methods into a single unit. So basically it's a class where you have the attributes and the fields and the methods defined so that we can define the behaviors of it, right? So which what happens with by making this particular class, you have directly restricted access to certain fields directly. So you are using certain access modifiers and you provide certain getter setters so that you are not directly accessing these fields. Okay. Inheritance, basically this is let's say you have one parent class and the child class. So all properties which are there in the super class, that is from the parent, right, it will be available to the child class. So so it will inherit everything, like every properties, every method which are not private and other details, right? So which what happens when we use inheritance is that it promotes the concept of reusability, and also there is a is a relationship which means that let's say A is the superclass and B is a superclass, so subclass. So now B is in relation, right? It can also be replaced with the A whatever B, right? So B is nothing but a kind of a subtype of A, right? So that's the is a relationship. Now polymorphism. So this particular objects when you are dealing with, right, it takes many form, right? So it can be method overloading, right, where at the compile time, or method overriding, right, at the runtime. So basically you will be dealing with method overloading and overriding. So that that gives you a compile time as well as the dynamic polymorphism benefit, and it promotes flexibility and also dynamic behavior as we have mentioned. Now abstraction, basically this is an important thing where it deals with the abstract classes and the interfaces. So here in this particular concept, we are going to hide the internal implementation and only show that particular essential feature. So it is used if you wanted to hide something, the internal implementation, only you're concerned about how those particular, I mean, if you are not concerned about how those are implemented, but you want to get something, right? Then you can use this particular abstraction feature. Hope this particular concept is clear to you. Now, what is method overriding and overloading, right? So basically, we just discussed about polymorphism. So it is compile time polymorphism and runtime polymorphism. So basically, when you're dealing with these two concepts, right, it is called I mean, it is related to a polymorphism, and it allows the classes to have methods with the same name but different behavior, right? So that's what they in short actually. But if you specifically go to method overloading, right? So this one, if you see, right, so it is a feature in which where you can have multiple methods with the same name, but they will have a different type of parameters, right? So in a way, you can deal with different variations, I would say. So there will be different implementation of a method's signature, right? So the return type can be same or different, but it does not play a very, I would say, important role in overloading. But at the compile time, I would say it is determined. And also know this particular method overloading is called static polymorphism. Okay, so the methods can differ with different parameter names or parameter types of parameter basically. Okay, so that's about method overloading. Now overriding is nothing but when you have a superclass and subclass is going to implement its own method that is already present in the superclass. This method will, I mean, it's a subclass and have the same name, same return type, and the parameter as a method which is defined in the superclass. So this is also called a runtime polymorphism, and the method whatever you return in the superclass exactly provides an implementation of that particular one in the subclass, and we can use at the rate override to ensure that this particular thing is being correctly overridden and other and the Java notices it, right? So and you can call, I mean, these methods which are defined in the subclass can be also be called with using the superclass using the keyword super keyword, right? So you can do that. Now method in the subclass cannot have more than restrict. So whatever we have defined at the subclass superclass, right, you cannot restrict it to the received access modifier then which is already defined, right? So you have that particular rule that you cannot restrict it, you can define the same thing, right? Mm. So in the table wise order, I have just placed this particular definition differences. Now, if you look at this, we have already discussed about the definition, the result, the return type, access modifier, the signature, right? They will depend on the type of things, right? So it will differ in that case. Now, what is the use of finalize, and finally keyword? Now, this is one of the popular question and most repeated question, I would say. So he would like to, because at the initial level, not very, I mean, many people doesn't, I mean, they must be knowing either final keyword or finalized keyword, but some of them literally not aware of the finalized keyword, although it is present in the finalized method, which is present in the object method, right? So they are not well aware of the concept. So uh, I'll explain here. So if you see final keyword, right, so as a keyword when it can be applicable for the variables, right, and the methods and the classes, right? So when it is declared, right, so basically when what exactly the final means is that once you assign some value, you cannot change it or right. So that's the essential behavior of it. Now, let's say the reference type of an object, right? And it is declared final. The reference type, whatever has been defined, cannot be changed. But the object state can still be modified unless the object state behavior is immutable. So that is what one of the, when you're dealing with reference type, right? That is a behavior. Now, if you give here, there is a max speed which is given as 120, and when you're trying to assign 150 over here, you will get a compile time error over here. So you will not be allowed to add as again edit that particular value. Now, when you're dealing with methods, there is a max so method which is declared as an final cannot be overridden. Now, let's say you have a subclass and superclass. So in the top superclass, you have written a method that's, let's say, make sound, right? So when you override in the particular class, you're trying to implement that, right? Override that. So if you see, you cannot override this particular method because it says that it's a final method, right? So that's what the subclass cannot do that. You cannot override it. Now, when you're dealing with classes, right? So when a class is declared as final, you cannot extend it and then you can implement it, right? So that's the preventive way, whether you doesn't want your class to be extended by someone and you want to restrict that inheritance feature for it. So that it's let's say for some security reason you doesn't want that particular any class to be uh, extending and doing its own modification. So that's how we restrict it. And here is an example. Now, when it is coming to the finalize method, right? So this is an, as I already mentioned, this is one of the method in the object class, and this is called by the garbage collector before any object is getting destroyed, right? So it provides an opportunity, or I would say a cleanup process for an object to perform cleanup, so that any resources like files, network, it can release those resources. So it is before it is moved to the or released from the memory. Now, when do we use it? That this is typically when you override it in a class to define certain cleanup behavior of an object, so that garbage collection can be taken care. I mean, how we want it, right? So now although garbage collector, which automatically calls the finalize method before declaring the occupied, I mean, which are occupied by an object, right? However, it is not guaranteed. So no matter you call 100 times, it will be only called whenever the JVM decides that, or the Java decides. And then there is a resource crunch, or let's say there is a algorithm which works on that part, and then it will actually call those and it will perform the garbage collection. So even though you implement that particular method, it is not guaranteed that you will be able to call that the moment you call this particular method. So it is better you do the resource management properly, right? So there is an example of how we can override that particular method, and then we have our own implementation, right? So ideally, we should not be using. I mean, generally, I would say we should not be using the finalize method as garbage collection is not predictable. But yeah, I mean, if you are having a resource crunch, you can deal using this particular way, right? So make sure you use Java 7 feature for that try with resource. Okay. Now, finally, keyword. So this is one of the keyword which is used with the exception handling, where you write a code which is always executed no matter what happens. But although there are certain exceptions, now regardless whether there is an exception thrown in your try class or there is an exception thrown, right? This particular finally block will be executed, which is written after try and catch, right? So it is placed, as I mentioned, after the try block, or optionally, I mean, if you're not writing catch, then it will be placed after try block. So, but normally try, catch, and then finally it is executed. So it runs in a sequence. Typically, we write in this particular method, we try to close some resources which are we have opened, or some database connection we have already opened, or you want to perform some cleanup activity, right? So it is always executed whether the exception is thrown or not, until as I mentioned, there are certain scenarios we'll discuss. If there is an exception thrown in a try block, let's say, so that the catch block, if it is written, right, then it will be executed after the catch block. Now, finally block will be executed after the catch block. So if you see here we are dividing with 0, which will ultimately the first block will be executed and then ultimately the finally block will execute. So if you see the output, it will execute the catch block and the finally block as well, right? So these three keywords, I would say, are used in a different context, and they have their different purposes, I would say. Okay. So what is composition and how it is different from inheritance? Now, many people get confused about what exactly is a composition, and this is very rare and also, I would say, an important core feature of Java. So there is a slightly difference in when it comes to, not slightly, but I will say a difference when it comes to the exact thing. So these are the two fundamental concept, I would say, of an OOPS, right? So which basically deals with when you have how the relations are defined between the classes. Now, let's say composition, we take it, right? So this is one of the design principle, and which is where the one class is made up of another object. Let's say, so you will be representing a as a relationship, right? So let's say you have some at the superclass, and also superclass has a subclass. Okay, so it's not kind of extending and then implementing its features or overriding its feature. It's something which is uh, encapsulating, or I would say has that particular, making as part of that particular, so you're including that particular component into it, right? So let's say an example, if you say class A, right, a car is it there, so you may have an instance of an engine, because class might have an engine, wheels, or I would say seats, whatever different kind of things are, which are inclusive of part of the core car, right? So now if you see, there is an engine has been written here, there is a separate class, right? But if you see, car has a part called engine, right? That is one of these parts. So now if you see, the class engine will be inside the car. So if you see private engine, and this is what composition it is called, right? So it's quite different when it comes to inheritance and composition comparison. But yeah, now inheritance is something we already discussed about. There is a concept of easier relationship, okay, and whatever superclass has got, it inherits the properties and the behavior, and it is called as an easier relationship. So that's a clear difference when it comes to composition and inheritance. Hope you got the concept. The constructor chaining in Java. Now, this used to be a frequent questions a long back, but depends on the interviewer, how experienced he is, and what kind of interview he is taking about. But this used to be a normal frequent question. So, what exactly the constructor chaining is about? It refers to a way where we call one constructor from another constructor in the same class, basically. Or in some cases it might be a super class, but that's how we call multiple constructor. So what happens is that it allows you to reuse certain codes which are written in the constructor, within the constructor. So there are different types of constructor chaining, right? One is within the same class, right? And from one which is from subclass to superclass, right? So when you're dealing with the constructor call, let's say you're dealing with within the same class, right? So in the constructor, you call another constructor of the same class using there is a keyword which is this. So you can call using this. So if you see here, now in the public car constructor, you will see if there is a this, and then you have given the parameters over there. Now if you see, there is another constructor which is written below that. Now you have that particular model and the year, right? So that's how you call it in the same class. But when you're dealing with superclass and subclass, right, so the constructor which is calling the superclass using the super keyword, right, the subclass, in subclass you will be writing that constructor, right? So if you see here, now this is an animal is in super class, and if you see, there is an animal called up constructor. But if you see in the dog, which is extending the animal, you see that there is a super and then the name, which is going to call the animal constructor. Okay. So what is the difference between checked exception and unchecked exception? So we already spoke in different other videos about it, but yeah, as a broader differences, or I would say at the hierarchy, when you take it from the throwables, right? There are different exception, whether it's checked exception or unchecked exception. Now they are categorized in that way, right? So one checked exception are the one which is going to represent a situation that could be potentially can be recovered, or it should be explicitly handled by the code at the compile time. But unchecked exception basically they represent some kind of errors that typically indicate certain bugs, or actually the or incorrect usage of an something, or the handling them is not mandatory. So it's not kind of mandatory to handle this, right? So in that case, we use unchecked exception, right? So that's the difference. And also when it comes to checked exception, we have IO exception, SQL exception, class not found exception. Unchecked exception, basically there is a null pointer exception, array index out of bound exception, array remedy exception, right? So these are the differences. Now, what is synchronized keyword? Although this particular keyword is used a long back now, nowadays like we are very rarely using it, but it's one of the core important feature keyword as well. So let's say this is used. I mean, when do we use synchronize is when you want to ensure the certain method or a block of code which has to be accessed by only one and only one thread at a time, not multi-threaded accessing certain resources, right? So you have to restrict certain threads at a time so that it provide a thread safety, and also there is a consistency between the person who is going to call in the database, right? So it ensures this safety of it, right? So uh, in that way, it actually prevents the data corruption, inconsistency when there are multiple threads to access, right? So data might be different when threads are accessing resources at the same time. Okay, something is updated, something is not updated, or something it is wrongly updated. Okay, so that's what. So in a multiple way we can handle it. One is using the synchronized method, and one is using the synchronized block, right? So when you're dealing with the method and you marked it as unsynchronized, so only one method can execute that particular method on that particular instance at a given time. Now, if this particular static method, it is, I mean, you have to take and acquire a lock for it, and then you have to call this particular method. Now, when it comes to synchronize block, right? So you are not overriding a method, you are not rewriting the using the method signature. You are actually implementing inside that particular block of code, and also certain code, not the exact whole method, right? So you have a precise and control code where you want to implement this so that whole method is not blocked up, or has to be taken care of locking and then unlocking, right? So you can specify the the section. So it's quite reduced, and also I would say suggestible. So the important points I would say when they are dealing with synchronized, right? So there is an object locking. So when a thread enters into some synchronized method, right, or a block, it should acquire the lock, okay, or a monitor, or actually basically on an object, so that it has to access it, right? Thread blocking. So other thread who is trying to access that particular code must wait until that particular current thread finishes it, okay, or releases it, right? And synchronized keyword, it will basically use for preventing the race conditions when we are dealing with multiple threads at a simultaneous time, or dealing with the shared resources, right? So that's where we use this. Now, what is the purpose of transient keyword? Basically, this is used in context of where you doesn't want your fields to be not serialized, or you doesn't want this to be stored somewhere, right? So when an object when you're dealing with certain object, and you want to certainly serialize and then unserialize it, and you want certain attributes to not to be having some certain values when it was tried to save, right? So that's where what you do is that you serialize, I mean, mark that particular field as a transient, So the time of by object being converted into a byte code, this particular field will be excluded. Okay, so this is one of the preventive way to let's say you're using certain passwords or certain important data or certain temporary data basically, right? So you can choose to mark this particular field transient, and you doesn't choose to save that particular data. Although this can be kind of looked at as a part of a security feature where it doesn't disclose some details in it, right? Okay. Uh, Try with resources. We already discussed. This is one of the Java 7 features which was introduced for auto closing the resources, basically like databases or connections, right? So, in a way, when you try to write a code in a try with resource part, right, it will auto closes the resources which was already open, even though if you are not trying to manually take care of the closing, right? So, whenever there is no need of that particular thing, actually, this will be taken care for the resource cleanup and the auto closing, right? So in this case, you can avoid certain memory leakages, and there is a proper memory management, right? Um, so as I mentioned, it is working with the auto closable resources, which include some file input stream, buffered reader, right? So these resources are automatically closed using at the end of that, right? So it doesn't need to explicitly call certain dot close for any closing the connection in the finally block or finally method, right? So it will be automatically taken care, right? Now, what is the difference between fail fast, and fail safe? Now, this is in regards to the normal collections which can be iterated using the iterator, and also the way we are after the concurrency API being introduced, there are some fail safe iterators, fail safe classes has been introduced. So, what exactly? I mean, when you are trying to deal with an certain collections and you're going to iterate, right? We use iterators for iterating. Okay. So, so what happens is that when you're trying to iterate over certain collection and you're trying to, let's say, modify something or remove something, right? Or adding something. So it will immediately throw a concurrent modification exception. So while it is iterating, so this will restrict any modification internally which is going to modify. So it takes and I mean it constantly checks for the mod count whether something is modified or not. At the moment it finds there are some changes, it throws a concurrent modification exception, right? So that at the very that moment it will actually try to restrict that particular behavior to happen, right? So here is an example. Let's say one to the list one and two is added, and in the middle, if you're trying to add that, right? And you are trying to say iterated dot next, right? It is going to throw a concurrent modification exception. But when it comes to fail safe iterator, so this will not throw any exception if there is a certain modification during the iteration. So they can operate I mean why is that? Because they operate on a certain copy of a collection, so modification is not happening on the original, it is happening on the copy, right? So that's what the concurrency package, they have introduced a couple of classes which is copy on write array list, concurrent hash map, right? So it's safe when and it will be ignored and it will be properly handled, right? So that's how the difference between fail fast and fail safe. Now, what is garbage collection and what are the different types of garbage collection? Now, basically, we already discussed it is a process of automatically identifying certain resources which can be reclaimed and cleaning that particular resources so that which are not needed. So it will ultimately clear the memory, and also if there is a possibility of memory leakage, it will prevent that. Now, how it works is that there is a mark and sweep algorithm. I would say it periodically identifies which particular objects are not no longer needed, and it will remove from the memory. Okay, so there is a proper heap management happening. So what objects which are stored in the heap, right? So those are freed up by deleting that unreachable objects in the heap. Okay, So the process wise, when the garbage collection, I would say, so marking is quite important. So it identifies which objects are still reachable or not, which are in still use, right? So it will identify those. Now, sweeping is a process where you remove those unreachable objects and reclaim that particular memory. So compacting something optionally, but it is an optional thing, but it might be compact certain object resource to reduce certain fragment in the memory, right? Now, this is how there are how it works, but internally and also there are types of garbage collector. So one is serial garbage collector, which is used as a single thread for garbage collection, right? So it is best, I would say, for the single threading environment. Okay, and is used when you have a small application. Okay, and also if you have a small heap size. Now, parallel garbage collector is one of the used when you are dealing with multiple threads and you want to perform a garbage collection. So uh, this is used when you are trying to aim certain improvement throughout your multi core CPUs, right? So that's where we use it. So it is quite usable for multi core machines, I would say. The concurrent mark sweep is collector is a this is used for minimizing certain applications pause time by doing certain GC work concurrently in the application. Right. Now this is suitable for a low cost time application, which is that particular requirement, I would say. But G1 garbage collector one first is an huge, I would say, I mean, it provides a huge throughput and also a low latency. So this will basically divide your heap size into certain regions, and it will perform garbage collection in those region in a parallel, right? So this is used for an application which are quite huge and has got low latency requirements. Okay. So I hope you got this particular internal implementation and also what are the types of garbage collection. Now, different types of memory areas in the JVM is quite important, I would say, because it will give you an internal picture of what is happening when you are playing with certain language and what you are dealing with certain variables, methods, classes, right? So what internally happens, where exactly these are stored in which area, right? You'll get to know. So this is also you'll get to know how efficient it is that it is trying to handle its resource in optimized way, right? So there is a specific purpose which is written so that automatically it releases that particular resources or proper hand memory management is happening, right? So first of them is that heap. So all the objects whichever whether they which are instance of an classes or let's say arrays, right? Those will be stored over there. Now garbage collection, which I mean, this is taken care by the garbage collectors, right? So it is completely managed by it. Now, as I mentioned, it is divided into sections of like young generation, old generation. So it will have a portion where certain after the cycle of the garbage collector, those objects will be moved to the long live that is old generation. Okay. Now stack. Now stacks are which will store certain local variables, method calls, control flow. Now this might be a thread specific, or I would say it will have their own stack, right? Because they deal with our in their own stack. Now, data which is cleared when the method execution completes, right? So that would be the scope of it. So after, I mean, when the method is called, I mean, the data whatever it is being run and inside a particular method scope, right? It will like complete that. It will clear that. Now, method area is a meta space, I would say, in Java 8 and later. Now, class level data such as class definition, method parameter, method metadata, static variables, right? These are stored over there. Now, these particular things are basically shared among the across the multiple threads, I would say, in the JVM. Okay, so what is PC register? Now, PC register is a program counter, I would say. Now, this stores certain instruction related, I mean, current instructions being executed by the thread, and it is specific to the thread I mean, it has got their own PC register also. The native method stack. Now this is store certain native methods which are not related to Java, okay, which are either written in C, C++. If you go to the core API classes and open some of them, you will find that native methods, okay, which have that particular implementation, right? So that's where we use it. Now code cache, this stores compiled. This is JIT compiled code actually. So this is also shared among all the threads. I hope you are able to understand this particular details. Now, in between, like there was a question asked about whether you can write a code to find the frequency of a character in a string, right? So, ideal way to handle is to store that particular iterate. I mean, you iterate it and then you try to store that particular in the hash map because ultimately a hash map is you will store the key and value pair and ultimately it will have a unique key, right? So you will be able to quite easily find what how many of them are stored multiple times, right? So if you see where the for loop has been written, then we will be putting inside that, right? And we'll add it, right? So that's how we write that particular logic over here. Okay. Uh, how would you perform pagination and sorting in Spring Boot Data JPA? So now, ideally, like if you want to implement certain pagination and sorting functionality, right? The very first thing what we have to do is that we have to make use of the pagination sorting interface or a JPA repository. So these are the repository level interfaces dealing with Spring Data JPA. Now, pagination when we take, right, it will help your large set of data which will be brought in a result set in a smaller manageable part, right? So it's kind called pages basically. So you can specify the number of pages and also number of size of the pages, right? So let's say based on your logic you can use this many rows will be fetched up in a certain right. So when the logic, I mean, you can write your own logic in terms of the count based on the count of the data we have. Sorting. Now sorting will be I mean it will be ordering that particular result based on one or more fields. So you can either use it in ascending order or descending order, right? So this is how we write it. So you first extend the repository. This is one of the repository you have to extend that. So here is an example. And then if you see the find method, you will see that pageable thing over here. So pageable object is created over here, and then there is a sorting also applicable here. So here, if you see, here we have defined that pageable page is equal to page request dot off. So you see that 0, 10, and then sort by the name of as an ending order. So you can define those ascending or descending or how many pages, right? So those all things be defined. So here you can perform this. Now if you see employed a repository and then you're going to find that using that particular pageable feature, right? Um, this is I've written an explanation, but yeah, basically, if you see here in the create page, whatever we have done, we have specified which page from the starting it should be, how many item per page should be there, along with that certain sort logic we have given ascending or descending, right? So it will return a page object which will have the repository methods which will retrieve the total number of pages, current pages, sizes, and etc. content, right? So this is quite helpful when you have large set of data and you wanted to load it in a chunk. Now, how do you handle lazy loading? And there is a problem called n plus one when you're trying to deal with a Hibernate, right? So lazy loading, well, first of all, when we look into it, right? So this is an when you're dealing with the related entities, right, and are not and which is not particularly loaded when a parent object is fetched, but when it is only accessed that at that particular time, it is loaded, right? By default, Spring Data JPA it uses a lazy loading feature that let's say for many to one or one to many relation because it has got uh, the relation is quite huge, right? So there can be more than one possibility of having that particular instance. So that's why it automatically by default restricted. But let's say either if it is not handling, so you can actually define the fetch type as lazy in a default as a default way, but so it will not immediately load that, right? So what will happen is that the lazy initialization exception is avoided when you are accessing the loaded relationship outside of the transaction context. So in the service layer basically, right? So this will avoid the situation to happen. Now, the best practice is that you access the lazy loaded relationship inside the transactional context only, inside the same session, I would say. Now, when you're using DTOs to fetch that particular field in a simple, I mean, when you're dealing with DTO, right, you use that particular in a single query only, you get that particular detail, right? Now, n plus one problem, what we discussed about is it's a problem which is like you have an entity which say you have one to many relationship and you wanted to load. So there is a list, right? So separate query has to be executed, load that first thing, and then your separate query has to be executed to fetch that internal entities, right? So which is quite inefficient, I would say. Solution to this is that you're writing as a join to fetch that. So it will fetch that particular thing at the eager time only, and it will avoid calling the and the parent and also the child objects, which are n number of them, right? So if you see here, there is a query written over here with the where clause, and there is also a join fetch written over here. Now you're trying to get that particular department details. So this is how we write it. So it will solve that particular problem. So here is an example what we have given, right? So if you see here, I mean, when we have written this particular thing, right? So um, there's an entity graph which will, I mean, which relationship should be eagerly fetched up. Now if you see here with the find B, right? There is an annotation which is used to fetch the related entities, right? Eagerly in a single query itself. So this will prevent your n plus one issue over here. That's how you deal with the second n plus one problem. Now, fetch strategies, there are certain fetch eager, fetch lazy, right? So you can define those in terms of what is your current requirement. You want to immediately load it or not. Okay. So that's depends like whether it's a last set of data. So you can, and instead of calling it, you can use the lazy, or else if there is no performance input or your, I mean, there should no, if it is not causing any performance issue, you can use that. Okay. Transactional context. So lazy loading collections are accessed within the transaction. So there is an at the rate transactional annotation which should be used for managing the transaction basically. Okay. So what is the difference between Hibernate and JP? Now JPA, if you see, it's standard for any ORM basically for Hibernate, let's say, right? So it's a standard API for ORM. So providing certain basic features for managing certain entities, database operation in a vendor specific way, right? Now Hibernate is an implementation, I would say. So the framework which implements the JPA specification, and on top of that, there are certain additional advanced features that are which are not basically provided by the JPA. Okay, so it can be independently used of the JPA. I mean, it can be used independently of the JPA, but it is often along used, right, with Java application, I would say. So as we already know, I mean, we discussed, JPA is nothing but a specification, and Hibernate is an implementation. Now, there are some uh, when it dealing with an object-oriented way, you have to deal that particular query language like in a JPQL way. But when you're dealing with Hibernate, it has got their own criteria, API, native query, HQL, right? So the different way we can access, right? Now, JPA does not provide any caching inbuilt functionality, but yeah, Hibernate has got the first level and the second level caching. For this JPA, when it comes to configuration, we have a standard configuration which can be defined in the persistent.xml. But Hibernate, we have certain CFG configuration files which we need to define when you're dealing with an XML, right? So, and let's say JPA, right? There is no specific vendor related thing we have to do. But Hibernate, yeah, we have to deal with custom dialects and other related things. Uh, that's what the difference. Now, what is JPQL and how it is differ from SQL? So, JPQL is nothing but a Java persistent query language, and is a query language which is used to query the entities in the relational database. Right? So it is part of the Java persistent API, JPA basically, and it is used to operate on certain objects and their attributes, not directly using the database tables or the columns, I would say. Okay, so it's an object-oriented way of dealing with the database. So it will work with the entities and their attributes. So when you compare it with the SQL table, it has got the columns, right? Similar way, it has got fields. Okay. So database now abstraction. JPK is kind of an abstraction, which is, I mean, when you deal with a specific um, syntax, I would say, right? So it is quite portable when you are dealing with relational database, and you can switch easily, right? So, and also when you're dealing with any query based on the entity relationship, like one to many or many to one, so this will this will be handled in an entity, right? But SQL, you have to manually handle it with the tables and the foreign key relationship. So here I've given an example of JPQL and the SQL, how it is written. Okay. Um, what is the difference between at the rate component, service, and the repository? Now, this is one of the annotations which are part of the component scanning mechanism when you're dealing with Spring-based applications, right? They are equivalent in terms of like how it is being registered, registering the beans in an application context. However, there is a slight different intent and purpose for it, and it gives a clarity whoever is going to implement or writing certain implementation, right? So at a general purpose level, at the very top, you have at the rate component, and if you see there are specific services, I would say at the rate service and at the rate repository. So now, uh, if you check at the component, right, it's quite general. It is general. It's not anything specific. But specific, it is service. If you see, it is taken from a certain layer that is when you're dealing with certain services, right? So where the business logic is written, right? Now, when you're dealing with the databases, right, or a DAO layer, you're using, we should be you are using at the rate repository. So in a different context or in a different layer, we use different annotation. Okay, um, that's what the difference. Now, how would you test your Spring Boot application? So this is one of the common question asked, because ultimately when after the code is being developed in many organizations, there is a restriction of writing a unit test cases, and also it should cover up at least 80% of their code coverage, right? Which is tracked, and also as a rule it is mentioned, right? So to improve the quality of the code, certain rules are followed. Now, when it comes to testing, right? So there are typically different layers written when we write our applications, right? REST API, services, repository, controller, right? DTOs. So different layers are used to achieve certain different functionality, and used to gives it plays their own roles to keep it separate, right? Uh, Testing is quite important when you are dealing with all these layers, right? So there are different testings, like unit testing is there, integration testing is there, web layer testing there, testing the REST API. You want to mock certain external services API. You want to test using the profiles, like different environments basically, right? So you want to integrate it with the continuous integration, that is CI/CD pipeline, right? So that's how different kind of testing is done. So I mean, when you're dealing with unit testing, basically, so it is quite focused on testing certain individual components, which are classes, which are written in isolation, or that doesn't need any full application context. But yeah, you can do that. So there are popular tools which are framework. I would say JUnit, which is used for testing it. You have Mockito for mocking certain dependency in it. We use Spring Boot test. Basically, it is an annotation and utility for testing, right? Um, Integration testing. Now, integration testing is used to test across different components, let's say layers, right? Surveys, repository, control. You want to test together as an expected behavior, it is working or not, right? So you usually load that particular Spring Boot to run this particular test cases. Now, there is this Spring Boot which can be used to run at the full context for the integration testing. So at the rate Spring Data JPA test, right, which is used for testing JPA repositories. Web MVC test, which is for Spring MVC controller. REST template, which is used for REST test API testing, integration testing. Let's say you're dealing with web layer testing, right? So at the rate controller testing, testing can be focused on interaction between different user interfaces, REST APIs which are written, layer. You can use web MVC test for testing, right? Or basically this Spring Boot test also for full integration testing. Mock at the rate, I mean, I would say mock MVC utility which is used to perform requests and assert certain responses without starting the full HTTP server. The web MVC test, which is used in the annotation base to test the web layer, that is controller. Now testing REST API, so we can use a REST template, test REST template or mock MVC for simulating the same type of HTTP request. Mocking certain external services or an API, right? So we can use we can test those particular services that rely on certain API or service. You can use mock beans or wire mocks to simulate the external resources. Now, testing the configurables and profiles. Now, what you can, I mean, we have profiles to configure different environment, like let's say test, feature, production, right? Such at the test profile, we can use our settings. We can set certain properties in the application dot hyphen test properties, right? We want to run certain CI/CD pipelines. So testing, we're running the test, right? So you indicate that there is a test environment in the, I mean, this you have to include this particular test case in the CI/CD pipeline to ensure the application is thoroughly tested before it is committed or let's say moved to the production. So we can make use of JUnit, Maven, Gradle to run automatically test this particular and integrate with CI/CD like Jenkins, GitLab, or GitHub. Now, how do you integrate a Spring Boot application with two databases? Now, this is quite a bit rare, and also many people are not aware of dealing with multiple database, because either in most of the organization you are dealing with a single database, but there is a as technology is evolving, and also based on the database, right, we need to uh, adapt ourselves, and also there is a possibility of using more than one database in an application, right? So there are certain configuration which has to be done when you're dealing with multiple data bases, right? So you have to define data sources, multiple data sources being some certain configuration has to be handled for each databases. So at the very start, you write some certain two details of the particular database configuration like URL, username, password, driver details, and etc. After that, you create a configuration class where you define a certain at the rate annotation, at the rate transaction management, and at the rate enable JPA repositories, and you give those particular packages, the entity manager related and the references inside it. You define certain beans, configuration properties where it is to load that particular properties, and you you have your own platform transaction manager, the method where you have to override the and define the entity manager. We have JPA transaction manager basically. So you have to write this particular thing to get that entity manager and also the platform transaction manager. Now, the second, similarly, we write I mean, same thing in a different configuration class. We're dealing with a different database. So we define the data source, the local transaction manager, and then platform, right? Transaction manager, right? Then ultimately, if you see at the repository layer, we can actually use this particular database specific repository methods, right? You can call here DB2 specific repository methods. So this is how you write and call those particular databases. Now, when you're using with the repository and all with the service side, right? So here, if you see there is a repository one, repository two, then calling the repository one dot save repository two, right? That's how you write this particular way and handle the multiple database. Now, what is embedded default embedded server, and in the Spring Boot, what is the default, right? Um, so there are quite a of them that embedded servers are there. One of them is the what is the default embedded server in Spring Boot. So when you're dealing with an embedded server, so you must be already knowing when you're dealing with Spring Boot, right? It comes with the default uh, embedded server. So one of the quite default embedded server is Tomcat. So it's a default one when you are trying to run your Spring Boot application automatically deploying in the embedded. So it is quite widely used, and also it's an open source server which has a servlet container for the Java application. So it supports later versions of servlet and API and JSP. Uh, you have a, I mean, also it is including default by default the Spring Boot starter web dependencies, right? You don't need to manually add up something dependencies here. Now Jetty is another embedded web server, I would say. So this is, let's say, when you're trying to run your application, by default, automatically it will be deployed on Tomcat. But let's say you doesn't want that particular Tomcat to be deployed. You want to customize it, and you want Jetty to be enabled, and you want to skip the or exclude the Tomcat, right? You can use this particular. You have to do certain configuration in the pom.xml. So here you have to add that particular Jetty starter library, and then ultimately you will be able to run that, right? Similar way, we have undertow where you have to specifically add that particular dependency and exclude the Tomcat. Right? So there are different one of them, and also you can quite customize it. Now, how do you implement security in Spring Boot application? Now, this is one of the important questions when you're dealing with microservices, when you're dealing with Spring Boot application, how are you communicating with different services, and how secure it is, right? So we have a Spring Security, which is one of the powerful and the customizable authentication and authorization framework used up. We can tight control the flow. So, I mean, we have written all the steps, like we have to first add the dependency, which is starter security. Now, after that, the second step is about we have to add the authentication setups. So by default, it is used basic authentication like username and password, which is we have to use. But to customize certain authentication, you need to define certain properties in the application.properties or YML. Like if you see the username, password, we have written over here in the application.property. Now, thirdly, we have to configure this particular custom class at the and you define in the at the rate configuration certain we have to override it and configure method, and then we have to define the ant measure, which of them are required, authorize request patterns, and what are the different permitted things, right? So we can define in the configure method where we can deal with, and at the rate enable web security is an important annotation which should be annotated with, and also there is a web security configure adapter we need to extend it. Now you can define certain roles and rules, users related information in the memory, that is in memory authentication related when you're using the JDBC based authentication or certain custom authentication with the database. So here is how we can define, and you can write similar configure related method. And there is an if you see a user detail service, this is being overridden, and then we have written that. So when you're dealing with in-memory database, you can use this particular for the user and for the role, like let's say admin or user, which uses the username and password, right? So we can use this. Now you can also define a certain custom login and login page, which can be enabled using the HTTP form login.log page, and we have to define the URL and we have to permit it around, right? When you're when to deal with the role-based authorization, right, you can have certain restriction to certain part of your application which you doesn't want other roles to be accessible. So you can define the role has a role or for it, right? CSRF protection basically, which is kind of optional, but you can disable it if it is required. So we can enable or disable, I mean, using it, right? So JWT, so it is also an optional, but it's used in authentication, stateless authentication basically. So when you are dealing with any multiple API, right, and you want to use JWTs and JSON Web Token for authentication purpose. So instead of session based, we can use authentication, user authentication over there. So we can integrate it with the token based HTTP headers, and we can authenticate the user. Now, what is microservice architecture? It is an architecture design type, so which is used for building an application as a collection of small and loosely coupled application, independent, deployable, I would say, services or application. Each microservice is responsible for doing certain specific function or a domain related and communicate with each other, right? So either using the well-defined API, which is defined, which either using HTTP or messaging protocol. Now, microservices can be developed and deployed and scaled up independently. That's one of the advantages, and it offers quite flexibility and agility in development to the teams, so that you can the development is quite faster in terms of delivery and agility, right? So what are the important key aspect of it is that it is quite independent, right? So each microservices when we are developing, right, it focuses on a single functionality like user management, payment processing. It doesn't deal with too many things, right? Decentralized. Now, data management. Now, each microservice has got own their database, right? So it promotes the data isolation, and also there is I would say uh, dependency between the thing. It is reduced. Now it is quite loosely coupled. So because each microservices are independent, one service is I mean failure, which is not going to impact the other ones, right? Scalability. Now each services can be scaled up independently on based on the demand, some request, right? So it quite improves the performance of an application. So uh, you have resilience, there is failure on one of the services. Let's say if there is certain failure, so it should not impact the entire system, right? If we have certain retries mechanism, fallback mechanism, circuit breaker design pattern is applied, so that it is maintaining the service availability. Now, what is the benefit of it? It's quite flexible in development, right? So different teams can work on different features and functionality independently without affecting others. Scalability, it can be scaled up to that particular each individual service level based on the load it is receiving. faster releases. So the development cycle is quite easy. The development is quite deployment is quite independent and easy. So the releases can be sent quicker. Challenges with respect to microservices that it is, yeah, I mean, more services has to be dealt, and there is an increasing complexity when it comes to managing the communication, data consistency, and also the deployment also. Now, when you're dealing with microservices, there is a distributed system, so we need to efficiently manage between the inter-service communication. So there might be a probability where we have to take an extra overhead of handling the error handling across the distributed system. Okay, so that's what the challenges are. Now, what are the common design patterns when you are dealing with the API design microservices, right? So as we mentioned, it is an architectural design pattern which is used for efficient communication, scalability, and maintainability. So the RESTful API is one of the first one where we design the common patterns for building the API in the microservices. Now, the use of HTTP methods like get, post, put, delete for communication, and then resources which are represented by the URLs, right? So here is an example where we wanted to perform an CRUD operation. We can use get, user, post, then we can use orders, right? We can use this. Now we can use GraphQL as well, so where it is in one of the query language for API that allow clients to request exactly the data which they need, avoiding certain bulk and or unnecessary data which has to be written, right? So it gives a flexibility, and also it is the way how the client wants to handle the retrieval process from different services. So it gives a client flexibility. GPRC, it's an Google Remote Procedure Call. This is an high performance language agnostic remote procedure call framework. This is, it uses a protocol that is called protocol buffer, that is protobuf, for defining certain API and supporting the bidirectional streaming, I would say. So when you want to have a high performance a communication between the services, right? Especially there is a low latency is a ask. In that case, we use this particular GPRC. Event driven. This is one of the popular way when we want to send or use some message brokers like via like Kafka, RabbitMQ, ActiveMQ to facilitate the asynchronous communication between the services, microservices. So we, I would say we can use this particular we want to have that particular. Uh, at the same time, we doesn't want the response, right? We can deal with the. There is no hurry of getting the response. I would say in terms of those services, we can make use of this particular asynchronous, right? So there is no blocking happening here. Uh, Now API gateway, this is one of the single entry point for all the client requests which are going to land on the application. So this is which will then route to the appropriate microservices. So basically it's an I would say kind of restricted security where it doesn't allow your requests to be handled until it is being secured and authenticated or authorized at a API level. Even if it is okay, then it is forwarded into the particular resource microservices. Okay. Mm, but the benefit of it is that it will simplify your client communication. You want to aggregate certain multiple uh, microservice related responses. You want to handle authentication. You want to handle certain uh, too much of request being landing on the server that is rate limiting, logging something. We can use that, right? So it's quite helpful. CQRS is command query responsibility segregation. So this is used as a separate read and write operation in a different model. So commands is basically used for writing, which are handled by the command model, and also queries which are used by the query model. Right. So we write different operations for to deal the performance of the complexity. So separate APIs are written like post and get for different things, right? And a service mesh. Now this is one of the, I would say, abstraction, which is when you're dealing with microservices over the network, uh, and it handles certain load balancing, security, and service discovery related things, right? So the complex communication which is there, right, which is across the distributed system, right? You need certain uh, I would say features like traffic management, services, and failure recovery also. So that's where we use service mesh. So managing the communication, I mean the microservice interaction, which is using the sidecar, like Istio proxies for communication between the services. Now we have API versioning when they're dealing with the maintaining of an application or the services, right? We need to maintain the backward compatibility so that when there is a certain rollback needs to be done, you are quite ready with the versioning, right? So it's quite useful when you wanted to certain client who are using on the old version, certain client which are using the latest version, and we want to test certain before going live on the certain things, right? So um, they can be configured and maintained like that. API gateway. Now, what is API gateway and what role it plays is that so it's one of the I would say a server that will as an entry point for all the requests which is going to the client, right? So in the microservice architecture, so it is a route, I would say, for all the incoming requests, so that it handles hand it over to the appropriate microservices, right? So it can aggregate the response, it can handle the various cross-cutting concerns like authentication, logging, load balancing, rate limiting. So quite a features are handled by the API gateway. So as we already discussed, like requesting the routing. So the route requested from the client to the appropriate microservice is done by API gateway based on certain request URL methods and other factors, I would say. API aggregation, I would say it can aggregate certain responses from the different microservices into a single response, and the interaction is quite, I would say, simplified, right? By reducing the number of calls, I would say. Authentication authorization can also, it can be securely done by JWT or OAuth, and also it's in a controlled way, I would say. So it ensures that authorized user can only access certain specific features or services. Load balancer, it can distribute certain requests which are landing on a multiple instances of a microservice to ensure the high availability of an application, and there is fault tolerance which is taken care. Right? Rate limiting and throttling. So it can help prevent number of requests landing on a client, or if there is an attack kind of thing which is preventing the overloading the resources and ensures the fair usage of this particular usage and no resources is overloaded. Okay, so logging and monitoring, I would say the gateway can collect certain log matrices and monitoring for all the incoming requests, right? So it can improve the observability and troubleshooting feature, I would say. Cross-cutting concerns like API gateway, it simplifies certain, I would say, cross concern like caching is there, response is there, transformation is there, security policies is there. So it has got quite a benefit when it comes to API gateway, right? Uh, Simplifying the client communication benefit, if you see, so the interaction with a single endpoint, right? So client only need to have a single entry point, that is an API gateway, even though it is trying to gather the data from multiple microservices, but ultimately it has to first hand it over to the API gateway. Now this is where the centralized management. So API gateway is nothing but a centralized management system, because it plays a key centralized way provider, as I would say, where it is dealing with the security, logging, rate limiting, reducing the complexity or load on the resource, right? That's where it centrally manages all. Now, what is the difference between asynchronous and unsynchronous communication? Now, when you are trying to request certain resources or you want to get in certain data, and when the client waits for certain responses after we send a request, right? That is what the synchronous communication is about. It has to wait until the response is get. But when a client sends a request and it doesn't wait for a request, that's what is asynchronous, right? Now, the communication style, if you see the request response, right? It's a blocking way of communication, but when it comes to asynchronous, it is a one-way communication and it is not blocked, right? So that's how internally it is taken care. Now we use protocols like when it comes to synchronous communication, HTTP, gRPC, REST API. Now when you're dealing with asynchronous, we are RabbitMQ is there, Apache, Kafka is there, right? We have different event-driven systems. The client is dependent on the service for the response, but client is, in this case of asynchronous, client is independent of the service and it can proceed without waiting for it. Now, the response time, the client has to wait for the immediate response, but when it comes to asynchronous, there is, I mean, the response can be delayed. The client can continue working on other processing task, right? But now, in dealing with synchronized with the real time, let's say some debit has to be happening or login has to happen. So these are all things which are requiring an immediate response. But let's say you have to run certain background communication or if certain event has to be published, a certain system has to get some data on a certain timeline basis. So we can make use of asynchronous communication. Now, when it comes to synchronous communication, in terms of scalability, it is quite less scalable as client waits for it, right? There is a bottleneck. But when it comes to asynchronous, it can be scaled up, it can be operated at individual level, right? So that's a benefit. Error handling is quite immediate, I would say, but asynchronous when you're dealing with it, it's an overhead, I would say, an extra thing has to be taken care for it. Now it is quite simpler to implement it, easy to track also because you get the upfront response and you also debug. But asynchronous is quite complex. It requires certain message brokers or event processings to happen so that it might take time to resolve the issue. Now, slower when you're dealing with services, service is delayed, right? So your response also is slower, right? So the performance is impacted. But when it comes with asynchronous, you are it's quite faster, and client doesn't wait on it. Uh, what is chatting? Now, what is chatting, and when it comes to NoSQL databases? Now, sharding is nothing but a technique which is used in NoSQL to distribute the data across multiple servers or nodes that which will improve the scalability and the performance of the database. Now the data sets is divided into small manageable pieces called shards. So each of them which is stored on a different server basically, right? This helps to spread the load, allow the database to handle more data, right? And I mean then which are there, apart from I mean instead of single right server which could manage, right? So sharding is particularly I would say quite important when it comes to NoSQL databases, but which are often used in the distributed system because large data set is used and it goes very rapidly. Now, distributed data across multiple machines, right? And sharding will ensure that the database can scale horizontally. Meanwhile, like more servers can also be added as the load increases. So it will not degrade your performance. Now, when it comes to fault tolerance, it will enhance and also it is it has got the availability, high availability, I would say. So each sharding is independent and also if one of them is failed, it will not bring down the entire system, right? So it plays a very critical role in achieving the high throughput, basically sharding, right? So and very low latency operation in a large scale application can be taken care in this. So it's quite efficient in terms of NoSQL. What is the difference between primary key and unique key? So, if you see primary key, it ensures that each record in the database is unique. But the unique key, it ensures that each value in the column is unique, right? That's what the difference is. Now primary key will not allow null, but now unique key allows null, but only one null per column. Number of key, the table can have one only primary key, but table can have more than one unique key. Automatically creates a unique index on a column, but for the primary key. But when you are trying to use a unique key, automatically creates a unique key on an index. Right? Now it is uniquely identifying each record in the table, but it is used for, I would say, basically without being enforcing, I would say. Now, what's the difference between delete, truncate, and drop? Now, they are used in a different purposes and also in a different way. Basically, in terms of deleting the row, right? You can delete all the rows or certain rows. Truncate will definitely remove all the rows, and drop will not only remove, it will delete the complete structure of the table, right? Data and the structure. Now, you can have certain where clause condition in delete, but truncate will have, we cannot have a where clause. We can directly have to remove all the, there is no condition applied. Now, and drop will entirely remove the table, right? The table of the structure, when it comes to delete, right, it is still maintained, it remains intact. Now, table structure, when it comes with truncate, the table structure is intact, but data is removed here, basically, right? That's what happening. But table, now when it comes to drop, it will delete the table structure only in schema. Now, delete is quite slower because it will delete each row by row. But truncate is quite faster when it is delete because it will not, it is not performing individual deletion. Right? Drop, it is also quite fast and it will remove the entire table. Now, logs of each particular delete is maintained, right? In delete, now logs only certain in truncate, right? You cannot roll back. Okay, so that's the problem. Now, no transaction log are maintained for drop. You cannot roll back as well, right? Uh, Triggers are fired for each row deletion. So when you're dealing with deletion, right? So triggers are fired for each rows. Truncate, it will not fire any triggers, right? But when drop also does not fire any trigger. That's how we deal. When it comes of locking, right? So delete, it will actually acquire a row level locking. Truncate, it will acquire a table level locking. A drop also, it will acquire a table level locking. Hope this video was helpful to you, for the people who are attending interviews and also wanted to attend WIPRO interview. Please share this video with all the needy people who are learning and also wanted to know about the interview process. If this video was helpful, please don't forget to like, subscribe, and hit the bell icon. Uh, Thank you. Thank you for watching.